Hello, and welcome to your lecture on matter. This lecture covers sections 1.4, 1.5, and 1.6 in your textbook. You'll use this video a couple of different ways in this course. First, during the Study Skills module, you'll use this video to practice your note-taking. Think about all the different note-taking methods you learned about. Which method will work best for you? You'll revisit this video during the Matter and Measurements module. Rewatch it after reading your textbook. There will be quizzes on this material, and the material from this video is included on Worksheet 1. In this lecture, we're going to discuss the classifications of matter, the states of matter, and the physical and chemical properties of matter. So first, what is matter? Matter is anything in the universe that has mass, and mass is the measure of matter in an object. In chemistry, we study the composition, behavior, and structure of matter. And matter can be broken down into several different categories. The classification of matter. First, matter can be broken down into substances and mixtures. A substance is a form of matter that has a finite or constant composition and distinct properties. A mixture is a combination of two or more substances in which the substances retain their identity. Now let's do a knowledge check. Look at the four examples shown here and determine whether it's showing a substance or a mixture. Pause the video and see if you can do this on your own. So our first example is milk, and milk is a mixture. It's made up of water, proteins, and lipids. Next, we see gold bars. Gold bars are a substance. It's just made up of gold. We then see a salad dressing. Salad dressing is a mixture. It's made up of oil, vinegar, and you can see herbs and spices. And then water is a substance. Now substances can be further broken down into elements and compounds. An element is a substance that cannot be separated into simpler substances by chemical means. And to date, there have been 118 different elements identified. You can find them all on the periodic table of elements that's shown here. Now, a compound is a substance of two or more elements that are chemically united in fixed proportions. They have distinctly different properties than the elements that make them up, but they can be reduced to their starting elements through chemical reactions. Let's do another knowledge check. Look at the examples shown here and determine whether it shows an element or a compound. Pause the video and see if you can do it on your own. Now, example A is a compound. It's made up of two different elements, represented by blue spheres and white spheres. Example B, which is water, is also a compound. Water is made up of one oxygen atom and two hydrogen atoms. Letter C is an element. It appears that there is only one element represented here by the purple spheres. And letter D is a compound, made up of two different elements represented by red spheres and green spheres. Letter E, gold, is also an element. You can find gold on that periodic table of elements that we looked at earlier. And letter F is an element. While there appears to be more than one atom making up each cluster, they're all made up of the same element. And so we would categorize this as an element. Now mixtures can be further split into homogeneous mixtures and heterogeneous mixtures. A homogeneous mixture is a mixture of two or more substances whose composition is the same throughout, and you can't identify the different substances just by looking at the mixture. In the example we see here, there's a solid that's made up of red and black spheres being mixed with a liquid that's made up of blue spheres. When you mix the two together, you can see the red, black, and blue spheres are all evenly distributed throughout the sample. This is a homogeneous mixture. A heterogeneous mixture is a mixture of two or more substances whose composition is not uniform, and you can identify the different substances just by looking at the mixture. The example we see here is sand and sawdust mixed with water. So you can see the sand in a layer at the bottom of the beaker, with the water sitting on top, and the sawdust floating in the water. You can easily identify the three different parts of this mixture. Knowledge check. Determine whether the examples shown here are homogeneous or heterogeneous mixtures. Pause the video and see if you can do it on your own. Letter A shows a homogeneous mixture. There are two different substances that make it up, the purple spheres and the teal spheres, but they're evenly distributed throughout the sample. Letter B, our salad dressing, is a heterogeneous mixture. You can actually see the herbs and spices floating on the top of the salad dressing. Letter C, stainless steel, is a homogeneous mixture. Stainless steel is made up of different metals that are mixed together, but you can't identify each metal on its own just by looking at the steel. Letter D, rusting metal, is a heterogeneous mixture. You can easily identify the rust from the metal. Letter E, which is milk, is a homogeneous mixture. While it's made up of different proteins and lipids, they're all evenly distributed throughout the liquid. And letter F is a heterogeneous mixture. This is another mixture that is represented by purple and teal spheres, but you can see all the teal spheres are clumped together at the bottom with the purple spheres on top, so it's not evenly distributed throughout the sample. States of matter. In this course, we're going to study three main states of matter: solid, liquid, and gas. In the solid state, the molecules and atoms are closely packed together, creating rigidity in the object. In the liquid state, there's some space between the atoms and molecules. This allows the liquid to be poured and to take the shape of whatever vessel it's in. In the gaseous state of matter, there's a lot of space in between the atoms and molecules. This allows gases to be compressed or expand, depending on what's happening around it. Properties of matter. In addition to its composition, matter can also be classified by its properties. First, physical properties. A physical property of matter can be measured and observed without changing the composition or identity of a substance. And a physical change is the observation of a physical property. So, for example, the melting point of water. We can see that water here is a liquid, solid, and gas. All three different states are shown, but it's all still water, and so it continues to have the same composition. A chemical property is any property of a substance that cannot be studied without converting the substance to some other substance. And a chemical change is the observation of a chemical property. One example is burning hydrogen gas to form water. Another example is when you start with a raw egg, put it into boiling water, and end up with hard-boiled eggs. Another aspect of chemical properties are that they're typically not easily reversible. So you can't take your hard-boiled egg and reverse it back into a raw egg so that you can then make scrambled eggs later. Knowledge check. Determine whether the changes listed here are chemical or physical changes. Pause the video and see if you can do this on your own. So water freezing. Water freezing is a physical change. You start with water and you end with water. All that's changing is the state of matter. Iron rusting. Rusting iron is a chemical change. Rust is formed through a process called oxidation. While you can remove the rust from the iron, you cannot take the rust and turn it back into iron. So it's actually a chemical change. Cooking a hamburger is a chemical change. And typically cooking anything will be a chemical change because it actually causes changes in the bonding within the food. Melted chocolate hardening. This would be a physical change. Very similar to when water freezes, when melted chocolate becomes solid, its makeup remains the same, it just changes states. And carbon and oxygen forming carbon monoxide. That is a chemical change. You're starting with two different elements, carbon and oxygen, and through a chemical change, creating a new compound. Properties of matter can also be classified as extensive or intensive properties. An extensive property is a property that depends on the amount of matter being considered. If I'm weighing a brick of gold and I remove some of the matter or some of the gold, then the mass is going to go down. So mass is an example of an extensive property. If I have 100 milliliters of water, but then I add more water to it, the volume will increase. Volume is another example of an extensive property. An intensive property is a property that does not depend on the amount being considered. If I have that same brick of gold and I cut some off, the color isn't going to change. So color is an example of an intensive property. Temperature is another example of an intensive property. If I have two 100 milliliter glasses of water that are both 25 degrees Celsius and I combine them together, the temperature will still remain 25 degrees Celsius. It doesn't increase because the two glasses were mixed together. Knowledge check. Determine whether the properties listed here are intensive or extensive properties. Number 1, the volume of a sample of acetate is 25 milliliters. This is an extensive property. If I add more acetate, the volume or the number of milliliters will increase. The density of mercury is 13.534 grams per centimeter cubed. This is an intensive property. If I add more mercury or take mercury out, the density will remain the same. You'll learn more about density in a future chapter. The boiling point of water is 100 degrees Celsius. This is an intensive property. It doesn't matter whether I'm boiling 8 milliliters or 8 liters of water. The boiling point of water will always be 100 degrees Celsius. The mass of a sample of iron. This is an extensive property. If you add more iron to the sample, the mass will increase. And the arrangement of the elements in a diamond. This is an intensive property. The carbon atoms that make up a diamond are in a specific arrangement or crystal structure. And it doesn't matter whether you have a diamond chip or a 3-carat diamond, the arrangement of those elements are going to be the same. And that concludes the lecture on matter. If you have any additional questions or you're confused, there's a number of things you can do. First, reference your textbook for clarification and see if you can't figure out where your confusion comes from on your own. You can visit the office hours of any of our teaching assistants. You can attend a supplemental instruction session, and always come prepared to class to discuss any questions you have with your study group. Every lecture ends with a chemistry pun, just to remind everyone that chemistry is fun. Today's pun comes from the Science Cat. Chemistry puns, I'm in my element.